Now see next question, question number 5 from exercise 1.3, sub question 5. If sin inverse of x raised to the power 5 minus y raised to the power 5 upon x raised to the power 5 plus y raised to the power 5 is equals to pi by 6, show that dy by dx is equals to x raised to the power 4 upon 3y raised to the power 4. So first we have to simplify the given function, then we have to differentiate that. So write in solution given part. So write given sin inverse of x raised to the power 5 minus y raised to the power 5 upon x raised to the power 5 plus y raised to the power 5 is equal to pi by 6. We transfer the sin inverse to right hand side. So we get here x raised to the power 5 minus y raised to the power 5 upon x raised to the power 5 plus y raised to the power 5 is equal to sin pi by 6. Sin pi by 6 means sin 30, and we know that sin 30 is equal to 1 by 2. So we replace the sin pi by 6 by 1 by 2. So write left hand side terms as it is, x raised to the power 5 minus y raised to the power 5 upon x raised to the power 5 plus y raised to the power 5 is equal to 1 by 2. Now transfer this x raised to the power 5 plus y raised to the power 5 to right hand side. So we get here, therefore x raised to the power 5 minus y raised to the power 5 is equal to x raised to the power 5 plus y raised to the power 5. Now at the same time we transfer these 2 to left hand side. So we get in left hand side 2 into x raised to the power 5 minus y raised to the power 5 is equal to 1 into. So multiply by 2 into x raised to the power 5 minus 2 into y raised to the power 5 is equal to multiply by 1. That means we have to remove just bracket x raised to the power 5 plus y raised to the power 5. Now transfer the variable y terms in one side and variable x term in one side. So we write here x raised to the power 5 to left hand side we get 2x raised to the power 5 minus x raised to the power 5 is equal to, we transfer this minus 2 raised to the power y raised to the power 5. So we write plus 2y raised to the power 5 plus y raised to the power 5. So we get here 2 times x raised to the power 5 minus x raised to the power 5 as x raised to the power 5, and here we get 3 times y raised to the power 5. Now differentiate with respect to x. So here derivative of x raised to the power 5 is 5 into x raised to the power 4. Here derivative of 3y raised to the power 5 is 3 into 5 into y raised to the power 4 into dy by dx. So here 5 get cancelled, we transfer 3 to left hand side. So we get here x raised to the power 4 upon this y raised to the power 4 also to left hand side. 3 into y raised to the power 4 is equal to dy by dx. Now see here, we have to show dy by dx is equal to x raised to the power 4 upon 3y raised to the power 4. So we write this as dy by dx is equal to x raised to the power 4 upon 3y raised to the power 4, hence proved. Now see next sub question. If x raised to the power y is equal to e raised to the power x minus y, then show that dy by dx is equal to log x upon 1 plus log x its bracket square. Here if we observe the left hand side, this is of the form f of x raised to the power g of x. That means by taking log we have to solve this, or we have to simplify this first, then we have to differentiate. So write in solution given x raised to the power y is equal to e raised to the power x minus y. So taking log on both sides, taking log on both sides. So we write here log of x raised to the power y is equal to log of e raised to the power x minus y. Now for both the sides we have to use law of exponent. So we write this power in multiplication. So write this as y into log of x is equals to x minus y into log of e, and we know that log e is equals to 1. Here you write a reason. Log m raised to the power n can be written as n log m. So log e we write 1. So write in RHS x minus y into 1. So we write here x minus y into log x. Now differentiate both sides with respect to x. So here we have to apply product rule for this. So before differentiating it, we transfer this y to left hand side. That means we reduce this in one variable form. In y variable. So we write here minus y to left hand side, y into log x plus y is equal to x. So take y common here. So we write here 1 plus log x is equal to x. Therefore y is equal to x upon 1 plus log x. Why we convert this in the form x upon 1 plus log x? We use quotient rule here, and if we observe the right hand side, in denominator we require 1 plus log x its bracket square. That means when we apply here quotient rule, then we get in denominator 1 plus log x its bracket square. So for that we not directly use the product rule for left hand side and subtraction rule for right hand side. We first see which value we require. So we require in denominator 1 plus log x its bracket square. So we transfer this minus y to left hand side and take y common. So here we apply quotient rule for differentiating this function. So right here differentiate with respect to x. Now we write derivative of left hand side as dy by dx. For right hand side we have to apply quotient rule. So write 1 plus log x as it is. 1 plus log x into derivative of x with respect to x is 1 minus x into d by dx of this 1 plus log x upon, or you can write here d by dx of x upon 1 plus log x, 1 plus log x its bracket square. So 1 plus log x as it is, derivative of x with respect to x is 1 minus x into, here we have to find derivative of first term plus derivative of second term. So derivative of 1 is 0, derivative of log x is 1 by x upon 1 plus log x its bracket square. So write 1 plus log x as it is. 1 plus log x into 1, we write 1 plus log x. Here 0 plus 1 by x is 1 by x. So write minus x into 1 by x upon 1 plus log x its bracket square. So here x get cancelled. So we write here in numerator 1 plus log x minus 1 upon 1 plus log x its bracket square. So this plus 1 minus 1 get cancelled. We write dy by dx is equal to log x upon 1 plus log x its bracket square. So in this way we prove dy by dx equals to log x upon 1 plus log x its bracket square. Now say sub question 7. If y is equals to in root cos x plus in root cos x plus in root cos x plus and so on up to infinity, then show that dy by dx is equal to sin x upon 1 minus 2y. This question is very important question because such types of problems asked many times in board exam. So see how to show dy by dx equals to sin x upon 1 minus 2y. So write in solution given part first. So we write here given y is equals to in root cos x plus in root cos x plus in root cos x plus and so on up to infinity. Now we denote this as equation number 1. Now we have to differentiate. Now here value is infinity, so we have to replace that value in terms of y first, because when infinity is given, that means infinity terms are given, that is not possible for differentiating. So we square on both sides here. So right here squaring on both sides. So right here in left hand side y square, in right hand side this outer square root get cancel only. So we write here cos x plus in root this cos x plus in root cos x plus so on up to infinity. Now if you observe, this is value of y, so we write this as cos x plus y and write here result from 1. So we get here y square equals to cos x plus y. We require dy by dx, so differentiate with respect to x. So we get here derivative of y square as 2y into dy by dx. Here we have to apply addition rule, that means derivative of first term, derivative of cos x is minus sin x, derivative of y is dy by dx. Now transfer this dy by dx to left hand side. So we get here, or we require here plus sin x, so transfer this minus sin x to left hand side. So we write here plus sin x and transfer this 2y dy by dx to right hand side. So already dy by dx is here, and we transfer this minus 2y dy by dx. So we write here minus 2y dy by dx. In next step we take dy by dx common here. So right here dy by dx in bracket 1 minus 2y. Now we require 1 minus 2y in denominator, so transfer this 1 minus 2y to left hand side. So we get here sin x upon 1 minus 2y is equals to dy by dx, that we write dy by dx is equals to sin x upon 1 minus 2y, that we have to show here. So in this way we have to square the given value, then we remove this outer root first, and again here value is in terms of infinity, so we replace this value by y again and we differentiate the given function. Now say next sub-question 8. This question is similar to sub-question 7. If y is equals to in root log x plus in root log x plus in root log x plus and so on up to infinity, show that dy by dx is equals to 1 upon x into 2y minus 1. So here we write given part first. So write in solution given y is equals to in root log x plus in root log x plus in root log x plus and so on up to infinity. We denote this as equation number 1. Now we remove this outer root, so taking square root on both sides, right here taking square on both sides. So in left hand side we get y square equals to, in right hand side this outer root get cancelled, so we get log x plus in root this log x plus in root log x plus and so on up to infinity. Now this is value of y from equation 1. So we write here y square equals to log x plus y. So write here from 1. Now differentiate with respect to x. So derivative of y square with respect to x is 2y into dy by dx. We have to apply here addition rule. So derivative of first term, that is derivative of log x is 1 by x, derivative of y is dy by dx. What we require here, we require dy by dx equals to 1 upon x into 2y minus 1. So we transfer this dy by dx to left hand side. So write here 2y into dy by dx minus dy by dx is equals to 1 by x. We transfer this dy by dx to left hand side, keep 1 by x as it is. Now take dy by dx common from left hand side. So we write here 2y minus 1 into dy by dx is equals to 1 by x. Now we require dy by dx, so transfer this 2y minus 1 to right hand side. So we get here, therefore dy by dx is equals to 1 upon x into 2y minus 1. So here we show dy by dx is equals to 1 upon x into 2y minus 1. 1 upon x into 2y minus 1. Now see sub-question 9. If y is equals to x raised to the power x raised to the power x and so on up to raised to the power infinity, show that dy by dx is equals to y square upon x in bracket 1 minus log y. So here this function is of the form f of x raised to the power g of x. So for writing the power in multiplication, we have to take log on both sides, that is we have to apply here law of exponent. So write here in solution given y is equals to x raised to the power x raised to the power x and so on up to infinity, and we denote this as equation number 1. So write here taking log on both sides. So in left hand side we write log y is equals to log of x raised to the power x raised to the power x raised to the power infinity. So we write this power x raised to the power x raised to the power so on up to infinity in multiplication. So write here x raised to the power x raised to the power x and so on up to infinity into log x, and we write this x raised to the power x raised to the power x raised to the power infinity as y. So write here y into log x. So write here reason from 1, here you have to write reason log m raised to the power n as n log m. So we differentiate this, and in right hand side we have to apply product rule. So write here differentiate with respect to x. Derivative of log y is 1 by y into dy by dx. Here we apply product rule. So first function into derivative of second, that is derivative of log x. So we write 1 by x plus second function, that is log x, into derivative of first function, that is derivative of y. So we write here derivative of y as dy by dx. Now we require dy by dx. So transfer this dy by dx to left hand side. So we transfer this log x dy by dx to left hand side. So write 1 by y into dy by dx minus log x into dy by dx is equals to this y into 1 by x. We write y by x. Now take here dy by dx common from both the terms. So write here 1 by y minus log x into dy by dx is equals to y by x. Now see which value we have to show. Dy by dx equals to y square. That means we have to cross multiply here in bracket. So we write here 1 minus y into log x upon y into dy by dx is equals to y by x. Now transfer this term to right hand side. So we get here dy by dx is equals to y into y. We write y square upon this x as it is, x into 1 minus y into log x. Now see the value. We have to show here dy by dx is equals to y square upon x into 1 minus log y. So here y log x, this value y log x we replace by log y. So for your convenience, write this as equation number second. So we write here y square upon x in bracket 1 minus log y, and reason from equation second. So in this way we prove dy by dx. This part is important here, but we have write log y equals to y into log x. Here we calculate the derivative as 1 minus y into log x, and we require in answer 1 minus log y. So we replace this y log x by log y. Now see next sub-question 10. If e raised to the power y is equals to y raised to the power x, show that dy by dx equals to log y bracket raised to the power 2 upon log y minus 1. So here right hand side is of the form f of x raised to the power g of x. So we have to differentiate. Before differentiating this, we have to apply log on both sides. So write in solution given part first. So write here given e raised to the power y is equals to y raised to the power x. So we write here taking log on both sides. Taking log on both sides. So write here log of e raised to the power y is equals to log of y raised to the power x. So we use here law of exponent. So write power in multiplication. Y into log e is equals to x into log y. Now log e is 1. So we write y is equals to x into log y. So if you observe here we write log y. That means we require value of log y. So we differentiate this function with respect to x. Then if we require the value of x log y in terms of y, that time we denote this as equation number 2. So write derivative of this first. So derivative of y with respect to x is dy by dx. Here we have to apply product rule. So first function into derivative of second. So derivative of log y is 1 by y into dy by dx plus second function, that is log y into derivative of first. So derivative of first, that means derivative of x with respect to x is 1. Now we require dy by dx. So transfer this dy by dx to left hand side. So write here dy by dx minus this x into 1 by y, we write x by y. So minus x by y into dy by dx is equals to log y. Now take dy by dx common from left hand side. So write dy by dx in bracket 1 minus x by y is equals to log y. Therefore dy by dx we cross multiply in this bracket. So we get here y minus x upon y is equals to log y. Therefore dy by dx is equals to, we transfer this y minus x upon y to right hand side. So we get y upon y minus x into log y. Now see, in numerator we require log y its square. That means we require log y there. So we write here this y as x log y. Here also we have to write this y as x log y. So write here this as equation number 1. So we write here this y as x log y into log y upon this y also x log y minus x as it is. So we take here x common from denominator. In a numerator we get x into log y into log y. We write log y bracket square upon we take x common. So write here x in bracket log y minus 1. So this x get cancelled. We get here log y its bracket square upon log y minus 1 as dy by dx. So in this way we prove. So when we require, you can write the equation number for putting that value. Here we have to show dy by dx equals to log y its square. So we write this y in terms of log y. So we write y as x log y from equation number 1, and here also this y as x log y, because in denominator also we required log y. So in this way we complete exercise 1.3.